Chapter 19 is all about acids, bases, and salts, and section 1 is about acids, bases, and the concept of pH. So first let's just talk about some basic properties of acids and bases. So acids conduct electricity, which means they are electrolytes. They also react with metals to produce hydrogen gas and a salt solution. Acids neutralize bases. We'll be talking more about neutralization reactions later in this chapter. Acids, you might know, have a low pH. So on the pH scale, they are anything that's below a pH of 7 would be considered an acid. They also taste sour. Don't try this at home because tasting acids can be very dangerous. But if you've ever tasted citric acid, that tart flavor of lemons or oranges, you're tasting an acid. That sour taste is from the acid. And acids also usually start with hydrogen. So if you're asked to identify an acid, there's a reference table that can help you with this. But the compound that has the hydrogen, the H in front, is usually the acid. Okay, bases also conduct electricity. They're electrolytes in aqueous solutions. They neutralize acids, just like acids neutralize base. Bases can neutralize acids. They have very high pHs, anything above 7 on the pH scale. And they feel slippery. If you get a base on your hand, it'll feel like you have dish soap on your hand, and then shortly after it will begin to hurt because bases can be just as dangerous as acids are. They taste bitter. Again, don't try this. It can be very unsafe, depending on the strength of the base. And an aqueous solution of bases are also sometimes called alkaline solutions. So a base is an alkaline substance. So that's just a word you need to know. And bases are usually metallic hydroxides, which means that they are ionic compounds. The cation is always a metal, something from the left-hand side of the periodic table. And the anion is hydroxide usually. Meaning an OH group with a 1- charge. So I'm sure you remember the pH concept from other science classes. So this is a pH scale showing the pHs of some common substances. In the middle here at 7, we have a neutral pH, so distilled water is neutral. Anything above 7 is considered a base or alkaline substance. And anything below 7 is considered an acid substance. So pH is actually, it's an abbreviation of a French word, which means hydrogen power. So the way pH is calculated is the inverse log of the concentration of hydrogen ions in the solution. So you don't need to calculate pH in Regents chemistry, you just need to know that it's a thing. And this is how they come up with the numbers that are on the pH scale. So a neutral pH is the inverse log of 1 times 10 to the negative 7, which is why we come out with a 7 for a number as a neutral pH. An acidic solution has a hydrogen ion concentration greater than that, so this is why the numbers come out smaller due to the inverse log math that we're doing here. Basic solutions have hydrogen ion concentrations that are less than neutral solutions, so they have large pH numbers. So here's a pH scale, and 1 through 13 with 7 in the middle are neutral pH. On the acid side, we have a very high concentration of hydrogen ions. On the base side, those substances don't, and they have a high concentration of hydroxide ions based on the definition of a base being a metallic hydroxide. So you might get questions asked about the concentration of hydrogen versus hydroxide ion, but you also might see this, an H3O with a little +1 charge. So let me explain what that is. So any time you have a hydrogen ion, something that's commonly found in an acid, but it's in an aqueous solution, it's going to react with the water from that aqueous solution. So the hydrogen ion is going to get added into the water. The H2O will now become H3O, and it will gain the 1+ charge from that hydrogen ion. So that is called a hydronium ion. So this is on table E. It's a polyatomic ion. And you need to know that in any acidic solution, if the hydrogen ion concentration is high, so is the hydronium ion concentration. They're essentially the same thing. Another thing you need to know about this pH scale that's often asked on the Regents is that each change on the pH scale is a times 10 change in concentration. So let's look at an example question that tests this concept. What is the pH of a solution that has a hydronium ion concentration 100 times greater than a solution with a pH of 4? So we'll start at 4, and we want a solution that is 100 times more hydronium than something that has 4. So to get this right, you need to know that hydronium, the H is H3O plus 1, and that's an acid. That's an indication of an acid. So if I move this over 1 from 4 to 3, that's a times 10 greater hydronium ion concentration, but I want 100 times greater. So I have to go to 2 here. So 10 times 10 is 100 times more hydronium going to the left. So my answer is a pH of 2. If they wanted 100 times less hydronium, then we would move to the right 2 places. It would be a pH of 6. So in summary here, you should know the properties of acids and bases. You should also know the basics of the pH scale. And what pH numbers are acids and which pH numbers are bases. Acids, of course, are low numbers on the pH scale, and bases are high numbers. You should also know the relative concentration of ions that are present in acids versus bases. You know that acids have high hydrogen ions and hydronium ions, and bases have high hydroxide ion concentrations. And remember that each number change on the pH scale represents a times 10 change in concentration. So that's the basics of the pH scale. In the next couple of videos, we're going to be talking about some of the different definitions for acids and bases and how to identify them.